Going live. Sure. Going live. Let me share my screen. Yeah, basic stuff. Uh, why? Entire window, entire screen but who? And let's go share. Uh, okay. Shared my screen. Let's go to the leak code. So this is the problem that we are gonna solve today. Rotting oranges. As you have seen in the yesterday's stream, I solved surrounding island. So today I will be attempting. So let's start. You are given a to n grid where each cell can have one of the three values. 0 representing an empty cell, okay. 1 representing a fresh orange, okay. And 2 representing a rotten orange. 2 representing a every minute any fresh orange that is food actually adjacent to a rotten orange becomes rotten. Okay, return the minimum number of the minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. Okay, I get what the question is trying to say. Every minute the adjacent fresh orange will get rotten. So what are we gonna do about this? How should we use DFS or BFS? The thing about rotten orange is you have to simultaneously check. We will first locate every rotten orange. Okay. Okay, four directional. Rotten orange, ash orange, or no orange. Okay, three states. I have three states. No orange, rotten orange, and a fresh orange. I can use DFS. As soon as find a rotten orange, start. You can use a loop for that. Sure. I can use loop. I can use loop. I need to find the time. I need to find time. Because simultaneously messages are going to get rotten. Hmm. Now how will I do that? Let's say again same thing. Mark oranges and this one by one. Start changing them. Using a loop. Using a loop. Let's start changing. Now the will be maximum time will be your time. Okay. Locate them. So locate them and start with one. Yes. Locate them and start with one. START start with one. But you cannot run the code concurrently. So when one DFS will complete, the another one will run. How can I find the solution for that? How can I do that? How can I do that? DFS will fail. Most probably. Hard to apply, I think. There has to be a better way to approach this problem. How can I do this using DFS? Okay. First, I'm I will need the location. Okay. I will need the location of the every rotten orange. From that rotten orange, I can start a BFS. Yeah, right. I can start a BFS. Every rotten orange, you can start a BFS. Okay. So every rotten orange, you can start a BFS and make roti. Okay. I got it. This should work. This should work. So what I am thinking is, hmm, let's play some music. La, 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 la. पहली दफा मैं कैसा जादू ये किया तेरा ना होया मैं जिया कहो ना कहो ये रातें बोलती हैं सनम तो सनम what should I play? Let's do this. Uh, this won't work as well. Let's say we have find all the rotten oranges. Now I can still not. I need to look for every orange, right? I have I have already made a function like BFS. So the another loop won't start until the first one ends, and that is the problem. That is the problem. I want them to run concurrently on every rotten array so that I can get the best result. How should I do this? I can make a queue. I can make a queue, right? I can make a queue. Oh yes. Oh yes. Oh yes. Oh yes. Oh yes. Queue. Queue. Story. How is that all done? Let's suppose. Let me show you what I'm thinking. Okay. Let's first try run this so that we know for sure this will work. Let's try run this code. Mhm. Okay. Don't. Okay. So what I'm thinking is this is a 3 by 3 matrix. Okay. Uh, and there are oranges. Uh, this orange, this orange, this orange, this orange. And let's say this and this orange are rotten probably. Store this one in queue. We will first of all we will loop through it. Make a queue. Okay. Now we find 0 comma 0 is rotten. Add this. Then we find uh, 0 1 2 0 1 2. Then what we will find that 2 comma 1 is also rotten. Add it. Add it in the queue. Now as we as it from the queue using the PFS, we will search in the 4 direction. Okay. So what we see, this one is fresh, make one is fresh, make it rotten, pop. Now add these two as well, these twos in the queue as well. So we are adding 0 comma 1, and now we are adding 1 comma 0, 1 comma 0. Both of them are in queue. This is pop. Now 2 comma 1. See, this is where game in control. 2 comma 1, 2 comma 1. So for 2 comma 1, what are we going to do? Same thing. We are going to do the same thing. We are going to traverse, make this rotten, make this rotten, pop. For every pop, a second counts as a second. See here, 2 pop, 2 second. Like 1 second, these two get rotten. No, 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 no. This is the same 1 second. This is the same 1 second. That is the thing. How can we count time? This is working, but how can we count time? How can we do this? How can we? Should be three for this one. Three. Now, how can we do this? We make two type of queues. Yes. What if we make two type of queues? See, will contain another queue. A queue within a queue. Easier and easier day by day. Maybe the DSAs. But this should work, I think. Because as soon as I pop this one, I'm not going to run this queue. I am going to run first this one, this one, then this one, then this one. So I'm going to run these queues first. Okay, these queues. And whatever I'm getting from this queue, I'm going to append it in this queue. So whatever I'm getting from this queue, append it from into this queue. This will work according to me. This is a queue. Same thing, but this time another queue. Uh, now, comma one will should be the first element of this queue. Okay, first. Similarly, that is the thing. I cannot pop it for the obvious reasons. I cannot pop it fully. But I don't need to. I don't need to pop. Right? Right? I don't. I I will pop them only if this one is empty. Then pop it. This is some crazy solution. I know their mind is working like this only for this question. Uh, will it work? I think it is. So I'm not popping anything. Traverse it. I will traverse it. And as soon as I go to the end of this queue. Okay. Now this is the important part. Go to the end of this queue. We count it as a second. This queue second. End of this queue is should be considered a second. Now how can you find the end of this queue? Simple thing. We are never ever appending an element in this queue again. We are just it. So you can just measure the length each and every time. Measure the length. Measure the length. That's it. That's it. Now, okay, let's go. This one might take. This might take some time, but it should. It should work. And if it doesn't work, then we are going to see the solution. That's how it works. If we don't know the answer, see the answer. We will know. So first of all, collections. From the collections, I'm going to import few collections from collections. Mm, I'll import DQ. DQ. Do I need DQ? Yes, of course I need DQ because we are going to pop it from the front. Mm. So there are going to be two queues. The big one. Big one. I can just write big. Do I make my job even harder? Ooh, DQ. Okay, DQ. Done. I'm going to traverse for I in range M, then for J in range and define M and M is equals to length of grid and is equals to length of grid. Okay, traversal done. Now if range 2, if a grid I comma j is equals to appended big dot append I comma j. I'm using the tuple here, tuple as usual. So now I have made. Let's make a total time. Total time. I the timing. White rabbit pointing at the clock we may play. Whatever. So I got my cue. Now I am going to perform a BFS, breath first search. So how are we going to do this? How are we going to do this? We are just going to loop through the queue again and again, right? Now while big big okay I wait. We are going to loop through it. Okay. We are copying anything. But to loop through it, you can just use for loop, right? For loop. So for we just need the index, or we need the list actually, or do we need the list, or just the first element? Yeah. What the fuck? Hmm. So what I'm thinking is we just need the first element of loop. We are making again. Hmm. Okay. So. Yeah. Actually, I should not just append the tuple here. I should in a list. In a list, yes. Guys, but we should use a list. Maybe better. Another, another queue. PQ. Aha, ha, ha, ha. Is it working? टप्पल बनाया अपन ने इस टप्पल को स्मॉल स्मॉल वाली बनाई स्मॉल बनाई ठीक है अब small dot uh, append db we are doing that's it. Could I have done this in smaller lines? Let's see. I think I could have, like, what can I do here is pick dot append dq, but I don't know it will work or not. That's why I'm not taking any risk. But let's search better way. Uh, Python, or maybe I should use AI. Will this work? Will this work? make this shorter. The same thing. Big dot. What I actually want. What I actually want is a queue containing multiple queues. So there is a way. Is there a shorter way? Is there a short way to do this operation? यही तो कह रहा था. But I think I'm doing it in tuples. I should be doing this in the list format. So I created a DQ uh, because the default of the DQ is a list, always a list. You can remove all this. Append will be working. Okay, this is good. Now what we want is the first element. The first element. Okay, first element. So how can we get the first element? Hmm. Let's say the cube. This will give you uh, a small cube. I mean, for small and big. For small and big. This will. This what is this? This is a DQ. This is a DQ. So what we want is the coordinate from. These are the coordinates we are getting from the DQ. First of all, let's pop it. Node node is equals to small dot pop left. Pop left. Okay. 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 See, that's the thing, right? That is the thing. We are never popping. We are never popping. We will small is empty. Small is empty. We need to remove the We need to remove the small. So for that, we using the DQ. Then we can use a normal list. Normal list will be doing the same thing, right? Hmm. Why are we doing? Why are we using the DQ? Why are we using the DQ? Huh? Whatever. I have used it, so I will continue. The small is empty. Remove from the base. Simple as that. Remove from the base. How can I know the small is empty? So we have to do this inside. Okay, inside this one. So if small is empty, if the length of small is SM and double L, what the spelling of small? What SM and double L? What? If this hence the length of the small is zero, just remove it from the big dot. Remove. Is it okay? Is it okay to do this? Because we are actually looping through the big, and this might this might create problems, right? We are looping through the list which we are changing. That's what I'm saying, right? We are looping through the list which we are changing. Will this create a problem? I am looping through a list which I am changing in Python without the index. Will it create problem? Oh, it is not creating any problem. But item 3 was completely skipped by the loop. What? So loop over a slice copy. Cha. To create a shallow copy while safely modifying the original list. Okay, I can do that. Okay, okay. Create a shallow copy. Remove and remove small. So okay, uh, I'm sorry, man. I'm sorry, small. I'm sorry. But here, what I see, I have Bob left. So these are actually x and y coordinates. Now I have to traverse in the direction. Graph is direction. Let's create it. A list of tuples. One minus one comma zero. Oh, wow. One comma zero and zero comma minus zero comma one. These are the directions we are going to work upon. Okay. We have x and y. Why is this blue? Why is the y blue? I have popped from the left. Oh, continue. Continue. To remove, continue. To remove, continue. Will this work? I don't know, man. Let's see. At the end, we will see if this work or not. I have popped from the left. I'm going to traverse in all the directions. For that, I will need the directions for P and Q. P and Q directions. Uh, N NX. Let's make it NX. New X. I mean X plus P. X plus P and new Y will be X plus Q. Now traverse while. Hmm. No. While the Y. Now I just need to go in four directions. I'm going into the four directions. What I need is I want to mark them rotor. Rotor. And this is conditions for traversal. Okay. First of all, should not be out of bounds. Should not be out of bounds. Obvious. And if it's rotten, it's probably in the queue already. If it's rotten, it's probably in the queue already. What I want is traverse only for the fresh oranges and mark them rotten. Hmm, mark them rotten. Hmm, should not come on. It should be fresh orange and fresh orange. Okay. Now outer bounds is simple. What is outer bounds? N by A NX NX is less than 0, and the NX should be uh, greater than equal to 0, and NX should be less than M, and NY should be greater than equal to 0, and NY should be greater than N. And for fresh oranges, grade NX NY should be equals to fresh orange. What is a fresh orange? A fresh orange is 1, right? A fresh orange is 1. Is this a cat? Is this a cat? No, I don't think so. This is a noun. So this is the fresh orange. It into the queue. Which queue? The small one. The small one. Append it. How are we going to append it? A tuple, right? A tuple. We're going to append it as a tuple. A new x, comma new y. Then you have appended it into the tuple. Now what I was thinking is, after this for loop is completed, we're going to add a time. Time. What time? Time plus equal to 1. big. I am removing DFS. I'm making the time. In theory, this should probably work. Theory should probably work, but this is not theory. Now I need to loop over again. Loop again. If there is fresh orange, don't think. Return minus one. Now to find this I in origin in F grade I gamma j is equals to 1 return minus 1. I don't think it will work in the first time. First try. Error. Syntax error. Oh, I need it and I never. See, I opened it. Opened it, closed it. Open it, never closed it. Ah, big is small, big is small, big is small. Runtime error. What is the problem? Sequence indexes must not be integer, not slice. So this doesn't work. So what was this guy saying? This fucking idiot. What was he saying? I should maybe I should make a copy. Huh? Huh? But there's the thing, there's the thing, there's the thing, there's the thing. You see, it does not work like that, my friend. It didn't work. I hope it doesn't give me the exact solution, man. Please don't give me the exact solution. Just tell me what I'm saying. So you are saying I should not create a DQ. I should not create a DQ. Okay. I will not create a DQ. I will create an empty list. Okay, empty list created. Then it should work. Right? Hmm. Will it work? Will it work? Directions is not defined. I have defined directions. So many mistakes. Now what? Wait. It is returning minus one in every case. Why are you returning minus one, my man? Are you? Am I not? Am I not changing them? Oh man, I'm not changing. If you append it, change it. Change it. Okay. So grid nx ny equals to make it two, man. Make it two. Going up, down, left, right, and not changing. Maybe, or else you have to return. Hmm. Alice, accurate. Accurate. Should be less than n. Ah, easiest mistakes. Now, why is it coming out 8? Hmm? Why is it coming out 8? Though maybe my idea failed. Idea failed. What I was thinking is अभी क्यों में एक एलिमेंट है ना वैसे ही जाओगे चार चार एलिमेंट देंगे चार एलिमेंट चारों को चलाना है I was thinking also wrong. It doesn't work like that. You have to run it until the small is empty. Until the small is empty. You have to run it until the small is empty. I cannot run it until the small is empty. Maybe I can. Maybe I can run it until the small. Yeah. No, I cannot. Length of the small and run it till that length. Okay. Yes. Calculate the length. Always calculate the length. Okay. Right. Uh, Size small. So how many elements are there? You have to run for that many elements. Okay. I don't care how many elements are there. You have for cloud and for K range size uh, size do not care about the K. What I care about is the times this loop is going to run. Okay. Yes. Not again. What the fuck is going on? This print is. Zero comma one and 1 comma 1. What a 1 comma 1. I think it's another loop. Another there are two elements in the cube. Okay, size 2, a small cube. size should get uh, 0, 2 correct, and 1, 1 absolute correct, 0, 2 and now the next one should be the 0, 3 second, 4 second, 1 second, 2 second, 1 second, 2 second, 3 second, and this one is 4 second. So I have achieved what I want to achieve. Okay, time is not in my favor. 0. Wait, 4, 5. What is this? What is this 3, 4, 5? 0, 1, 2, 3. Okay, I get it. I get it. 0, 1, 2, 3. Now, let me see the big font. Big. What is going on? Big. Big में क्या हो रहा है? The time. Okay. This is the big. What? It should if DQ is empty. I mean, I should remove the DQ then. Huh? There is an empty queue. Should get removed. So why is it not happening, guys? Why is it not happening? There is an empty DQ. If there is an empty DQ, it should get removed from the big queue immediately. I don't want to know the reason. It should get removed immediately. This is step. Now after copying everything. See, after copying everything, closing the loop for the small, right? Just remove this. Why did the empty list greater than zero? Okay, not equal to zero, greater than zero. Ah, why is it looping for the fifth time? Time is 4. When the time becomes 4, what does big become? Big become. See, at first, this is the traversal. Big become this at time equal to 1, which is correct. Big should become this at time is equals to 1. Then big become this 1 comma 1 0 comma 2, 1 comma 1 0 comma 2 at time equal to 2, which is correct, which is correct. Should be here somewhere. Now when time is equals to 3, big become 2 comma 1, which is also correct. Now time is 4, big become 2 comma 2, 2 comma 2, which is the end, the end, which is the end. I have to loop again to check for the 2 comma 2. That is the problem. I have to check one more time for 2 comma 2. So I am checking for 2 comma 2. So I have to give time minus 1. This does not feel right, man. Can someone give me extra examples? Extra, 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 extra. Mm, whatever. I need extra examples. Remove this. Remove this. You shall not pass. Output minus 1, expected 0. Why are you expecting 0? Huh? If you cannot, why are you expecting 0, my man? Where is it in the description? The need is zero. Huh? Mm-mm. Oh, no, but there is a return orange. But if there are no oranges, then you should return zero. No orange is equals to क्या बोलते हैं? No orange. Uh, true. The whole grid. The whole grid is zero. The sum of the grid will be zero, right? There are no oranges. The sum will be zero. Ah, this question was for me not easy. It was not an easy question whatsoever. I need help with this question. This was a really tiresome for me. Okay, guys, I think that's it for me. I cannot study any. I had easy, but no, this was not easy question. According to me, not easy question. Let's see what ChatGPT has to say about our solution. This is the best written note because you're always glazing. Uh, I can literally see your thought process. Every rotten I just start sweating simultaneously. So you create a big queue. Each queue represents one rotten. That is actually a logical attempt. The problem oranges are not independent VFS levels. They are not. Think about code spreading. Day 0, day 1, both in effect. You know, a simple say at minute 0, all these infected people. This is called multi source BFS. Instead of queue, you have one queue. All the rotten oranges start in the same queue. Why does the one queue work? Because initially, yeah. Now process level mark both oranges infect neighbors. Okay, notice something. They're exactly the oranges rotten at one, but then process another. You already know this better. Remember BFS. Q process 1, Q process 1 level 2, exactly the biggest realization. Look at this line. Why did you calculate now without realizing you were already implementing level order traversal? This guy is glazing me so hard. Uh, Level order traversal, that's huge. Now imagine instead of a small queue, you simply had a queue. Then size equals to length of the queue would naturally represent all oranges wrote in that minute. Why interview love this one? This usually the first time people realize BFS isn't just user queue, process nodes level by level. The level represent minute, distance, number or show depending on the problem. One optimizer instead or at the end. Put fresh oranges, count fresh oranges initially. Acha, fresh is equals to number of ones. Every time you wrote one, fresh is always fresh minus one. When fresh equals to zero, you are done. No second reverse. My favorite. I'm going to point out something you already didn't notice. Three problems above BFS looked like you visiting neighbors. You are writing in. This means you've discovered most important part of BFS pattern. Q, current level, next level. This is the exact pattern you see in when it tables a minimal length of the word ladder. Open the log shutters. One challenge for you: don't look at the editorial. Try writing the solution with one Q instead of big. Keep everything else same. Process the size exactly. I have no energy, man. It you motherfucker. It took me 1 hour 21 minutes solve this question. I thought it was an easy question at first, like surrounded regions. I don't have energy, man. I don't have energy to solve it again with one cube. Multi-source PFS. One cube can present many starting points. That's actually clever instinct. Oh, the official solution just here. Wait a minute, wait a minute. This guy, man, this guy. Okay. Should I play one game of chess now? Should I play chess? Should I? Should I? Should I? I think I should. Let's go. Let's end it on a win. Turn on the music. Turn on the music, please. On the music, please. Another version of me, I was in it. So in Chicago, I feel another version of me, I was in it. Another version of me, I was in it. This is too much pressure. The spawn. Too much pressure for this spawn. Motherfucker found out. There is too much pressure on this phone. I have no choice but to take it. This bishop is not developed. But Manard is developed, man. Manard is properly developed. I'm thinking of sacrificing my bishop, but this is doing nothing. So, what I'm gonna do now? Uh, is probably what I should do now is probably I think I should do this. Then I will go here, connect the rooks, attack on this open file, push this pawn maybe. You can go here, and then you can attack here. This is what I should look for, right? And this is also I should what look for. Go here first. Then I should go here. Okay. Mm, yes, I should save that. Oh man, if I had a darker bishop, that's gonna be crazy. Now here, I am attacking I need this round. This is not a and that is not the one. He is looking here, right? Great. I think I need to do something like crazy. Then I will jump here. Oh, smart. No. This bishop is looking here. Not a great spot. Not a great spot. I was. Uh, See, I know what you are thinking. I know what you are thinking. You are thinking, let's take this and do. Nah, shut the fuck up, man. Shut the fuck up. Not this easy. It's not going to be this easy. I need to take a bishop. Oh, this is the greatest part, huh? Don't you think? Ah! I'm an idiot. I'm an idiot. I'm an idiot. Idiot. Maybe I should not. Yes.